Alright, hello. This morning we are going to look at our last lesson, which is 11.5, which is two different formulas. One is the distance formula and one is the midpoint formula. So just like before when we looked at slope, slope is the angle or how steep or flat a hill is. Now we're going to look at not what the slope is, like rise 3, run 4. We're going to instead look at the distance from here to here. So now we're actually measuring a diagonal length, which we can't do by counting. We can't count this way. It doesn't work like that because we're not counting straight up or straight over. So we have to use this formula to find the actual distance between these 2 points. Then later we'll look at the midpoint formula, which will find the point that's right in the middle between the 2 endpoints. So like I said, if we have, let's say, this line, let's say it goes like this, and we want to find the distance, you can't find the distance between those 2 because we can't count like 1, 2, 3, 4, 5. It's not going to work like that. You can't count diagonally. We have to count vertically or horizontally, which doesn't work in this case because we would have to go diagonally. You can, however, if you have a length like this and they ask you to find the length or the distance between here and here, yes, you could count 1, 2, 3, 4. The distance would be 4. But this one, we need to use the formula. So let's take a look at our first set of points. We have 2 points. Now we don't need to actually graph them in order to find the distance. We're just going to plug what we know into this formula. So we have our 2 points. We need to label them with x and y. That's our first point. And then x and y here, that's our second point. So that's what we're going to plug in for our x1s, y1s, and so on. D is going to stand for the distance between the 2 points when we're done. So I'm going to start by drawing one big square root because that's what we have here. And then in parentheses it says x2 minus x1. So x2 is -4 minus x1, which is 6. That's in parentheses and it's squared. Don't forget the power of 2. Then it says plus y2 minus y1. So we have 7 minus and then a -2, and that one is also squared. Here we know 2 negatives make a positive, so I'm going to simplify first. If I'm following the order of operations, I have to do my parentheses first. You cannot square first. So in my parentheses, a -4 minus 6, that's a total of -10. Same sign, we're going to really add them up, so it's -10 squared. Plus, inside these parentheses, we have 7 plus 2, which is just 9. So 9 squared. So we've taken care of our parentheses. Now we're going to do our exponent. So -10 squared, that's -10 2 times. So -10 times -10 makes a positive 100. Plus 9 squared, 9 times 9 is 81. So then finally, we can add and subtract. 100 plus 81 is 181. And then this would technically be our exact answer, but we might want to simplify this. So I'm going to plug this in my calculator so I can get a more exact answer. So we have the square root, so second, and then x squared to get the square root in the calculator, and then 181, end your parentheses. And we get about 13.45. Since the second decimal is a 5, I'm going to round that up to 13.5. Those 2 squiggles mean approximately or about 13.5. So let's try another one. I'm going to start off by drawing a big square root and by labeling my points x1, y1 and x2, y2. So first I have x2 minus x1, so 2 minus a -2. Those 2 negatives make a positive. Don't forget the squared up there. Plus, then we have y2 minus y1. 5 minus 1, and that is also squared. Then I'm going to simplify even more. Just my parentheses, 2 plus 2 is 4, so we have 4 squared. And then 5 minus 1 is also 4, so there's another 4 squared. You can't add 4 plus 4 and make it 8 squared because we have to do our order of operations. Our exponent comes next. You can't add and subtract yet. So 4 squared, 4 times 4 is 16. So if 16 plus another 16 is really the square root of 32, which is not a perfect square, so let's evaluate that. The square root of 32 is really about 5.65 or 5.7 if we round up. If you want to put units on there, we don't know if they're talking about distance as in feet or yards or whatever it might be. So we can put units on there. You don't need to because it doesn't have a label. So next it says use the distance formula and the converse of the Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared. The converse of that just means if a squared plus b squared is c squared, then it must be a right triangle. To determine whether the points are vertices of a right triangle. So these are three sides of a triangle. We need to find the distance between each of the 3 points. So we need to do the distance formula 3 times. So I'm going to draw or separate out my paper here so that I have the ability or space to do this 3 times. Each one is going to be the square root. So I'm going to draw some square roots here. And first I'm going to look at just these first 2 points. I'm going to put them up here, -5, -2, and 0, -4. Then the next time I'm going to look at the next 2 points. So the second group I'll look at these 2. So over here I will do 0, -4, and -2, 3. Find the distance between those 2. And then finally I need to do the third set. So I already did these 2. I already did these 2. And now the third set of points I need to do between the first point and the last point. So -5, -2, and -2, 3. So I'm going to start with just the first one. This is my point x1, y1, x2, y2. So plugging into our formula, well, there's no formula on this page. I'll write it up here. It's really x2 minus x1 squared plus y2 minus y1 squared. You don't need to memorize this. This will be something that will be given to you on your MCA. Alright, so I'm going to start off by doing x2 minus x1. So 0 minus a -5, that makes a positive. And it's squared. And then plus y2 minus y1. So y2 is -4 minus y1, which is a -2 squared. Again, 2 negatives make a positive. So let's simplify. 0 plus 5 is really just 5, so 5 squared. -4 plus 2 is really -2 squared. So if we simplify this, 5 squared is 25. And -2 squared, it's not -4, it's a -2 times a -2 makes a positive 4. So we really have the square root of 29. For the moment, I'm going to leave this in the form of the square root because in the end, we're going to use the Pythagorean theorem up here, which will square it and leave us with a nice number. So let's try the next one. I'm going to use this as my first point, x1, y1, and then x2, y2. So we have x2 minus x1, so -2 minus 0. And then, oops, that's squared. Plus y2 minus y1, or 3 minus a -4, and that is also squared. 2 negatives there make a positive. So we have -2 minus nothing is still -2. 3 plus 4 gives me 7, so it's 7 squared. So in simplifying even more, a negative times a negative makes a positive 4. Plus 7 times 7 is 49. So altogether, we really have 49, 50, 51, 53, square root of 53. Alright, one last time. This is going to be my x and y, that's my first point. X and y, that's my second point. And then we're going to plug those in. x2 minus x1, -2 minus a -5. Those make a positive. And it's squared. Plus y2 minus y1, 3 minus a -2. Again, that's squared. And again, two negatives make a positive. I'm just following this equation that we learned on the previous slide. So let's simplify a little bit. -2 plus 5. There's more positives. There's 3 more. So it's 3 squared. 3 plus 2 is 5, so that's 5 squared. And then let's simplify. 3 times 3 is 9. 5 times 5 is 25. So if we add these together, we should get 34. So those are our 3 answers, but now we need to determine, is this a right triangle? We need to use the Pythagorean theorem, a squared plus b squared equals c squared. Well, think, which side is going to be c? Well, it's going to be the biggest side. So if you took the square root of all these numbers, it would make them all smaller. So if you took the square root of the biggest number, it will leave you with the biggest number left over. So this side will be c, and these ones are going to be a and b. So in our Pythagorean theorem, a squared plus b squared is c squared. So let's plug in what we know. A is really the square root of 29 squared. B is over here the square root of 34 squared. And C is the square root of 53 squared. So the square root and a square are opposites, they cancel each other out, so that's just 53. These also cancel each other out, so we have 29 plus 34, does that equal 53? Well, 20 and 30 gives us 50, 9 and 4 is 13, so 50 plus 13 is actually 63. So this is not a right triangle. However, we did find the distance between each of the 3 sides of the triangle. The second part of our lesson today is finding the midpoint. The midpoint of a line segment is a point that is equidistant or equidistant from the endpoints, meaning it's in the middle of the 2 points that you have. You can find the coordinates of the midpoint of a line segment by using the following formula called the midpoint formula. It's really just finding the average, or what's in the middle. So this is not an equation, it's rather an expanded form of a point, xy. So our equation up here simply takes our x's, adds them up, and divides by 2. That's the average of the first point, x. And then we're going to take the y's, add them up, and divide by 2, because there's 2 points, and find the average of the y's. The comma is in between here because we're just finding that point that goes in the middle. So it says find the midpoint of the line segment with the given endpoints. So I'm going to label this x, y, that's my first point, x, y, second point, and then we're going to plug them in to our midpoint formula. So we have x1 and x2, we're just adding them together. So x1 is 11 plus x2, which is -9, and then we're going to divide by 2 to find the average of that point. Then we're going to do the same on the other side. We're going to add our y's together. Doesn't matter which one, they said to put y1 first. So we have -4 plus -4, and we're going to divide by 2 on that side. So 11 plus -9, or 11 minus 9 is 2, and we have to divide by 2. -4 plus -4 is -8, and we have to divide by 2. So our point, 2 divided by 2 is 1, and -8 divided by 2 is -4. So this is the point that is the midpoint, or the spot that's right in the middle between those 2 points. Let's try one more. So here we have x, y, that's my first point, x, y, that's my second point. And we're going to plug them in and find the average. So that's why we're dividing by 2, because we have two points. Add up the x's and divide by 2, add up the y's and divide by 2. So my x's, we have 2 plus 5, and my y's, we have 7 plus 3. So if we simplify that, 2 plus 5 is 7, and divide by 2. 7 plus 3 is 10, and divide by 2. So our point, well now 7 divided by 2, not going to be a nice number, but that's okay. 7 divided by 2 in our calculator would give us 3.5. 10 divided by 2 is 5. So there is our midpoint, that is right in the middle between the two endpoints. So that is it for the midpoint and the distance formula. You don't have to memorize them, you just need to know how to use them. So there are a few you can cross off. Now, first part's just finding the distance. You don't have to know this middle part. The third part here is finding the midpoint, finding the average. And then on the back, I want you to try those 3 up here, and then attempt these ones as well. I didn't cross this one off, but you can cross off number 30 as well. That's a one that you don't quite need to know how to do. Alright, if you have any questions, please let me know. Otherwise, good luck.